मत करिए। नहीं, फिर
पूछताछ। कैसे स्टार्ट हुआ? कैसे पैक किया?
निकल जाएगा, छोड़ दीजिए, छोड़ दीजिए। आप बैठे हो ना क्लास में, बैठो आप आराम से।
तब क्या हुआ?
हेलो। गुड इवनिंग एवरीवन।
Good evening.
Good evening. Let's just start with the uh, RC circuit we were discussing, isn't it? So let's continue with that one. Okay. Okay. So after power generation and power rating, we discussed about the RC circuit. Okay, now at t equal to 0 and at t equal to infinity, there are two type of circuit. They will ask it in the question. Okay, t equal to 0 is called as initial condition, and t equal to infinity is called as the steady state condition or final condition. Okay, so right now, sometime in the question, what will happen? They will ask you, not in the steady state. Okay, or not in the initial condition. At some time t, what is the current in the charge in the capacitor? That is what they are asking in the question. Like, let's say the same example, or let's take one example and try to understand that one. Okay. Okay, up to the rated power we have discussed. Okay. So now, if you have been given a question where they are asking in the question not at t equal to 0, not at t equal to infinity. They're asking charge on the capacitor as a function of time. They are asking in the question. Okay, like let's say there is a circuit given to us. There is a capacitor here given, resistance R given to us, capacitor C. Okay, there is another resistance R and R given to us. There is a battery EMF E, and its resistance is also given R to us. Now they are asking in the question, what is the charge on capacitor as a function of time? Okay, find. Even though I'm asking you charge on the capacitor as a function of time, but to solve that one, we need to find out what is the steady state condition still. Okay, why? See the question. Find charge on capacitor, okay, as a function of time. Okay, this is what they are asking in the question. Okay, but even though in this question they could ask you what is the charge on the capacitor equal to infinity. So see, if you are in the equation on just one, wait. The question they are asking, find time. Even though they are asking in the question, charge on capacitor as a function of time. So if you have written the equation of charge as a function of time, did you see the equation of charge as a function of time contains like this? Q equal to Q max into 1 minus e to the power minus t by tau. Okay, so charge on capacitor as a function of time, if I want to calculate, this is what the equation will follow. So that means to solve this equation, we needed two things. What are the two things needed? If I can calculate what is Q max and what is the time constant, then what will happen? Our problem will be solved, isn't it? So what we are going to do, we are going to calculate these two things separately. Okay? How? A Q max means what? It is the charge on capacitor at t equal to infinity, isn't it? T equal to infinity. What is the charge on capacitor? That is called the maximum charge. So it means to calculate Q max, okay, to calculate Q max using t equal to infinity. Okay. What circuit condition you need? You need t equal to infinity circuit condition. Because at t equal to infinity, whatever will be the charge on capacitor, that is going to be the Q max. Okay. So t equal to infinity, what we do with the circuit? We open the capacitor and remaining circuit we draw as it is. है ना? So capacitor I have opened it and the remaining circuit I have drawn as it is. This is R, this is E, this is R, this is R. T equal to infinity, the capacitor got opened, right? If capacitor got opened, that means this R also got opened. So it means the only current which will be flowing, that is going to be in the lower branch, isn't it? So how much will be the current? See that R, and R, all three are in connected in series. So what is going to be current here? E divided by 3R, right? Ab we got the current. What is the Q max? Q max means the charge on capacitor in the steady state or t equal to infinity. And how do we calculate charge on a capacitor? By finding the capacitance into the voltage, right? And t equal to infinity is the time when the voltage is going to be maximum. That means I need to find out what is the potential difference across the capacitor VAB. VA minus VB. Now you see, if this point is A, I will call this point also A. And if this point is B, I can also call this point as B. But there is a resistor in between. But still I can say that. Why? Because this resistor doesn't have any current. So that's why I can still call it as what? That same potential. So this is B, so this is also B. So if I calculate VA minus VB, how much it will come? Current is E by 3R, resistance is 2R. So 2E by 3. So at t equal to infinity, the potential difference across capacitor is 2E by 3. So what is the Q max? The Q max will be C into 2E by 3. 2CE by 3. That means 50% of the question is solved, right? We got the Q max. Now the next motive we have is to find out the tau. Okay. So how to calculate the tau? So to calculate the tau, we have to follow three steps. Okay. What are the three steps? Replace the battery by a wire. Okay. Replace battery by what? Wire. Second is whatever the resistance is there in the circuit, keep it as. Don't do anything with the resistance. Okay. Open the wire. Open the capacitor. That is second step. Third, find R equivalent across what? Open end of capacitor. Let's find out what is going to be the R equivalent. Once we complete these three steps, then tau will be equal to R equivalent into C. But please keep in mind, this R equivalent is calculated across what? Calculated across the open end of the capacitor. Understood? So let's do the same thing in the circuit, whatever the circuit given to us. Let's follow these three steps. First step, battery was there, replace it by a wire. There is a resistance R connected. There is one more resistance R. There is one more resistance R, right? There is one more resistance R like this. And what is the second step says? Open the capacitor. Let's call this open end as X and this as the Y. Now let's calculate R equivalent across X and Y. To see that if this is X, can I say this is X? this is X, and this is something Z, Z, and Z. Let's calculate R equivalent across X and Y. So this is X and this is Y, and there is one more terminal Z. Look at this resistance. Is this connected between X and Z? Look at this resistance. Is it connected between X and Z? So connect it. That is R. This is connected in series between what? X and Z. So between X and Z, can I say that R and R in series? So 2R will come. And this is connected between what? Y and Z, right? Now I have to calculate the R equivalent. To see that this 2R and this R, are they connected in parallel? So 2R by 3 will come plus another. So what is the R equivalent? We got it 3 plus 2, 5R by 3. R equivalent we got it. So what will be tau? R equivalent into C. So now tell me, if I want to write charge as a function of time, we needed two things. What are the two things needed for finding the charge as a function of time? One thing was needed, Qmax, which we have calculated, 2C by 3. Another thing was needed is the tau, which we have calculated R equivalent into C. So what is going to be charge on capacitor as a function of time? So charge on capacitor as a function of time. Qmax we have calculated 2CE by 3, 1 minus e to the power minus t by tau. What is the tau we have calculated? 5RC by 3. Understood? So that is the charge as a function of time. Understood? So sometime in the question they will ask you t equal to 0. If they ask you t equal to 0, draw the circuit at t equal to 0. And what is the property of an RC circuit at t equal to 0? In a RC circuit, t equal to 0, capacitor behave like just a wire, short circuited wire. T equal to infinity, or they will use the different word. T equal to infinity, they will use it. Sometimes they will use it long time after closing the switch, or they will use the word steady state condition. So in the steady state or t equal to infinity, the capacitor behaves like open circuit. Okay. And third case is what? That any time t they are asking. So if you want to calculate at any time t, you need to calculate two things in the question. What are the two things? The two things are what is the maximum charge and what is the time constant tau. Once we calculate these two things, we will be able to answer charge as a function of time, because the charge as a function of time has q equal to q max into 1 minus e to the power minus t by tau. Clear? So this is about the charging of capacitor. Charging of capacitor means what? A capacitor, resistor are connected in the circuit, and there is a source of energy, which we can call it that there is a battery connected in the circuit. Second case will be the discharging of capacitor. Discharging of capacitor means what? That here we have a charged capacitor and we are not going to connect any kind of battery to that one. Okay? We are not going to connect any battery to a charge capacitor. Then it is called as what? The discharging of capacitor. Okay? So let's try to learn one example of discharging of capacitor. Okay? Two cases of RC circuit is there, charging and discharging of capacitor. Okay, so in the discharging circuit, what is going to happen? In the discharging circuit, we have a fully charged capacitor and a resistor connected with each other without any battery. Like this one, there is a capacitor. Okay, it has been fully charged. So initial charge, we are going to write it. Initial charge, let's take it as something Q naught. And what else we have? A resistor there, right? Capacitance is C. So what will happen? If this capacitor is charged one, so that will act like a battery, isn't it? And this is how the current will flow in the circuit. But as the current will flow in the circuit, what will happen? Energy will be lost, right? This electrical energy of the capacitor will be converted into heat energy, and finally the capacitor will get what? Fully discharged. Okay, you can write the equation like this. What is going to happen? So charge will what? It will be getting discharged, and capacitor will get discharged. So Q equal to Q naught e to the power minus t by tau again. What is the tau? If it is a single capacitor and single resistance, tau will be equal to R into C. But sometimes the multiple capacitor and resistors are there, then we have to follow the just the step we have taken to find out the time constant tau. Okay, so Q will be how much? Q naught into e to the power minus t by tau, and tau is going to be how much? RC. What will be current in the circuit? The current, can I write it dq by dt? But here I should write it minus, isn't it? Why minus? Because charge on capacitor will reduce with the increase in time. That's why current I am writing here minus dq by dt. So minus d by dt. What is the charge we have? Q naught. Q naught is what? Q naught is the initial charge. E to the power minus t by RC we have. Just differentiate it. What we are getting then? If you differentiate it, minus will be outside, Q naught outside. If you differentiate it, e to the power minus t by RC into minus 1 by RC. So what is the current we are getting? Q naught by RC e to the power minus t by RC, we can write it. Again, this Q naught by RC, you can also write it as what? I naught into e to the power minus t by RC. So here charge is also decreasing exponentially, and current is also decreasing exponentially. Okay. What else they can ask you? Potential difference across capacitor as a function of time, isn't it? So if you're writing the potential difference, charge on capacitor is a function of time. If I divide the charge on capacitor by, let's say, capacitance, that will become what? Potential difference, isn't it? Like Q by C, if I write it, what it will become? Q naught by C e to the power minus t by RC. What is that written? Is it written potential difference across capacitor? Right. Energy, if they are asking, what you will do it? Energy stored, can you write it? Q square by 2C. So 1 by 2C and Q square. Q square means Q naught square e to the power minus 2T by RC, it will come. Right or not? So you can write it U equal to Q naught square by 2C. Is it the initial charge, initial energy? And e to the power minus 2T by RC, like that. Clear? So these are all what kind of decay. You can see in the discharging circuit, everything follows what kind of equation? It follows the, uh, you can say, a exponential decay. Understood? It is all following what kind of decay? Every part it is following what? An exponential decay it is following. Understood? So these are all the cases. Let's take an example and try to understand. Okay. In this example, what is given to us? A simple capacitor and a resistor circuit is given to us. Okay. A fully charged capacitor is given, and a resistance R is given, capacitance C is given, Q naught is the initial charge is given to us. Okay. Question asking two things. Find time taken by capacitor. Find time taken by capacitor to discharge its charge to half. Charge to half. Okay. How much time it will take by capacitor so that the charge on capacitor became half of the initial charge. Okay, that is the first thing. And second thing, time taken by capacitor to discharge its energy to half. Understood both the question? Both are similar question, isn't it? Only the expressions are little bit different. Okay, so please try it and tell me what is that. Please tell me how much is coming with the time taken by the charge to become half, and how much is the time taken by energy to become half. Tell me how much is that coming. Trying, all of you. A question they are asking, how much time it will take the capacitor or its charge to become half. Okay, that is the first part of the question. Second part of the question, how much time it will take, how much time will be taken by capacitor energy to become half. Please tell me, all of you trying this one or not? Please tell me. What is the time taken coming for the charge to become half? So we should use the charge expression for that one, isn't it? If I'm using the charge expression, what we will write it? Q equal to Q naught e to the power minus T by RC, we will use it, isn't it? Now, charge is becoming half of initial volume. That means what? Q became Q naught by 2, and that will be Q naught e to the power minus T by RC. Right? Simplify it. Q naught get cancel out. 1 by 2 is there. Let's take log on both the side. So ln 1 by 2 it will become, and this one will become log ln e to the power something you are writing. So that will be minus T by RC. Okay, na? Ln of e to the power something if you are writing. So that will become just that power. Ln 1 by 2 means what? Ln 1 minus ln 2, right or not? And ln 1 is 0. So it will become minus ln, minus and minus will get cancelled out. What is the time coming to us? Ln 2 into what? RC. Or you can say that R into C into ln 2. Log 2 value is 0.69. So that is the time taken for charge to become half or 1/4 or something like that. If they are asking in the question, then we should use the charge expression. Next, they ask energy part. Of energy, what is the equation we have? U naught e to the power minus 2t by RC. Check the energy equation. Q naught square by 2c. We can call it as the initial energy. Right now? So e to the power minus 2t by RC, that is the only difference. Now again, as per the question, energy should become half. So u naught by 2 I will use it. Again u naught e to the power minus 2t by RC. Simplify it. If we simplify, u naught get cancelled out. Again we will take log on both the side. So ln 1 by 2 minus 2t by RC will come, right? Ln 1 by 2, that is minus ln 2. Exact same calculation we have. Minus 2t by RC. Minus will get cancelled out. So what is the time we are coming? RC into ln 2 divided by what? Half. So this is what we have. Okay. So whenever they will give you a discharging circuit, then they won't give you the battery connection. They will only give you what? They will give you the capacitor and resistor in the circuit. They will not give us any kind of battery in the circuit. So if there is no battery, you should think that it's not a charging, it is a discharging circuit. And if battery is still acting as a source, then what does it mean? You should consider it as a charging circuit. Understood? So in the charging circuit, generally three things has been asked. What are the three things? Circuit condition. Circuit condition means current, okay, in each branch at t equal to 0, t equal to infinity, and at any time t, what are the values of charge? Okay, so this is about the current electricity part. Now let's go to the magnetism. Okay, so in the magnetism we have two things. There are two type of magnet. Okay, so magnetism means what? There are two type of magnet. One is called what? The permanent magnet. One is called what? The permanent magnet. Other one is called as what? The electromagnet. Okay. So in the magnetism, we have to discuss about the property of two type of magnet. Okay. What are the two type of magnets we have? One is the permanent magnet. Other one is the electromagnet. Okay. What is the difference between the permanent magnet and electromagnet is that in permanent magnet, the material we are using has a uh, what you can say, always having the magnetic property, right? So it's the molecule of that magnet, like iron, cobalt, nickel. These are having permanent magnetic property. Means these materials can be magnetized, but plastic, wood, these are non-magnetic. So every material cannot act like a magnet. Okay, only some materials, which is the ferromagnetic substance. Okay, so depending on the magnetic property of material, we can divide the materials into different type. Okay, ferromagnetic, diamagnetic, and paramagnetic. Okay, clear? So permanent magnet, okay, which has a always a magnetic property. And electromagnet are what? Like a conductor. Okay, if a conductor is there, right, if you don't have any current in the conductor, it will not create any magnetic property. But the moment you start flowing the current in the conductor, and if you bring a magnet near to that, that magnet will start deviating. The reason is what? That due to the current, now that conductor is showing the magnetic property. So these magnets, which is getting the magnetic property because of the current are called what? Electromagnet. Understand the difference between the permanent magnet and electromagnet? So let's discuss the permanent magnet first, some property of the permanent magnet. Okay, permanent magnet means what? It's also called as the magnetic dipole. Okay, why magnetic dipole? Because every magnet has two poles. Okay, every magnet will have what? The two poles. What are the two poles of a magnet we have? It's a south pole and it's called north pole. Even the smallest magnet you have, it's always going to have the two poles. Okay, we cannot have a single pole magnet. Even if you break this magnet, what will happen? Again, the two pole will form in the two different pieces which we are going to have it. Okay, so this is called the south pole and this is called as the north pole. Okay, south pole and this is called as the north pole. Okay, so every magnet has what? The two poles, and these poles are called as the south and north pole. Is that clear? So depending on how strong a magnet is there and how do we decide the strength of a magnet? The strength of a magnet is decided by the pole strength. Okay, pole strength, we represent it by what? Small m. What is this small m? This small m is called as the pole strength of a magnet. Okay, pole strength of magnet. Clear? And what is the separation between this south pole and north pole? Let's call that distance as something L. This is called as the separation between the poles. Okay, so we define a term called magnetic dipole moment. What we define? We call magnetic dipole moment, sometime only dipole moment, sometime magnetic moment. Okay, all these words have the same meaning. So what is the magnetic dipole moment of a bar magnet? Capital M we are writing. It is pole strength into the separation between the pole. Okay, what is the magnetic dipole moment of a magnetic dipole moment of a bar magnet? The magnetic dipole moment of a bar magnet is the pole strength into the separation between the pole. Clear? And it is also a vector quantity. Magnetic moment is what? It is a vector quantity. So what is the direction of magnetic moment? So direction of magnetic moment is from which pole to which pole? Tell me. From south to north pole. Understood? So direction of magnetic moment is from south to north pole. Here, if you represent the magnetic moment, you will represent it like this. M vector. This is the arrow representing what? The direction of M vector. Okay. So a permanent magnet will always have what? The two distinct pole. Clear? A permanent magnet is always going to have what? The two distinct pole. Even the smallest magnet, okay, micro level, if you go right, even you break the magnet into small micrometers, still what will happen? The magnets are going to have what? The two different poles. Understood? Now if we break a magnet, what it will change? Let's try to understand. Okay, let's say a bar magnet is given to us. Okay, there is a bar magnet. Let's say this is the south and north pole. Its a pole strength is a small m, a small m. Now we can break this magnet into two ways. What are the two ways? The first way is what? That I am going to break this magnet like this. See that? This is the magnet we have, and we are cutting the magnet what? Perpendicular to length, you can say. Transverse direction or perpendicular to length. So after cutting, the two portion will form, will have what? What remains unchanged? So the two portion which will form, their pole strength will remain unchanged, and the length will get what? Length will get divided. Understood? So if I cut it now, the two distinct portion will form, isn't it? Like this. This is going to be what? South, north, south, north pole. Still it will form, isn't it? So if you cut it perpendicular to the length, then pole strength of the cut two portion will remain as it is. But if I say initially the length of the magnet was L, after cutting what it will become? L by 2. Let's say equal part we have broken, है ना? So L by 2, L by 2 it will become. This is what happen if you cut the magnet perpendicular to the length of magnet. Okay, so perpendicular to the length of magnet. We can also cut it along the length. Na? Like, let's say this is a bar magnet here, and we are cutting it what? Along the length, two part, one half upper, one lower half. So if you cut it along the length, then what will happen? Let's try to understand. So if you have a magnet of south and north pole like this, and you are cutting the magnet along the length, now what will happen? If you cut it this way, then the two portion will form, right? Both the portion will have what? The length remains unchanged in both the cases, right? This is the south and north pole. This is also south and north pole. But if you cut it along the length, if you cut it along the length, then what will change? It will change the pole strength. Let's say I have cut it in the equal proportion. The pole strength will become m by 2 and m by 2. And length remains what? Length remains as it is. But even you see that both the cases, what did you learn? You learn that first case, if you cut it perpendicular to the length, pole strength remain as it is and length becomes half. Second case, if you cut it along the length, then pole strength changes, length remain as it is. Understood? And one more thing, what is the magnetic dipole moment? So magnetic dipole moment is a pole strength into separation between the pole. And magnetic dipole is what kind of quantity? It is a vector quantity. What is the direction of vector? Direction of magnetic dipole moment vector is from south towards north pole. Understood? Let's discuss an example of this one. Okay. In this example, what is given to us? That a bar magnet is given to us. Okay. Initially, the bar magnet has dipole moment M. Understood? Initially, bar magnet has dipole moment what? M. And what has been done? It has been cut it into two equal part. Cut it into two. This is the south and this is the north pole of the bar magnet. It has cut it into two equal part, and after cutting them equally, what we have done? We have joined them like this at right angle to each other. Okay. After cutting, what we have done? We have joined them right angle to each other. Understood? Like this pen was there, no? Right? We have cut it into two parts. Now these two parts are there. They have been joined right angle to each other. Okay. So they are asking in the question, if initial dipole moment is m. Okay, initial dipole moment is capital M. Then find the new dipole moment of arrangement. Understood? After this kind of arrangement, what is new dipole moment? Let's try to find out. Okay. So please tell me how much is this coming? We discussed now. Initial dipole moment is m given to us. What is the new dipole moment after cutting it? Equal part. We have cut it into what? Equal part and joined it in 90 degree to each other. So please tell me what will be the new magnetic dipole moment of this arrangement. Okay. Please tell me how much is this coming? Are you calculating how much is the new dipole moment coming? Please tell me how much is this coming? See, initial dipole moment is m given to us. Let me consider that initially the pole strength is what? M, and initially the length is what? L. So as per the question, initial dipole moment is m. So can I say that m will be equal to small m into L? That is the first case, right? Second case, if you cut it in this manner, what will change? So in this manner, if you cut it perpendicular to length, then the length will only change and pole strength will remain as it is. So length has become L and L by 2 and pole strength remain as it is. So that means if you calculate what is the magnetic dipole moment of this one, so how much it will come? Small m into L by 2 will come. And for this one, if you calculate it, that is again going to come a small m into L by 2. Now look at these two dipoles after cutting. After cutting, is it the one dipole? And is it the second dipole? How much is that? M into L by 2. And how much is that? M into L by 2. So these two vectors are perpendicular to each other. So what will be their resultant? Is this going to be their resultant? Root 2 into ml by 2. Root 2 into ml by 2. Two vectors are there. Both are equal and both are perpendicular to each other. So resultant will come root 2 times of the value of them. Right? So what are we getting? ml by root 2 we are getting. And what is the ml as per the question? Small m into L is equal to capital M. So capital M by root 2 it will become. So new dipole moment after cutting and arranging it in this way is going to be how much? M by root 2. So always add the dipoles like a how you add the vector. Clear? Because the dipole moment is a vector quantity. Is that clear? Next example, what is given to us? A bar magnet is there. Okay, let's say this is the south and north pole of the bar magnet, and length of the bar magnet is L, Pole strength is small m given in the question. Now they are saying this bar magnet is bent into a semicircular magnet. Understood? This bar magnet is bent into what? A semicircular magnet. So now this will be the south pole and this will be the north pole, isn't it? So the question asking straight bar magnet, a straight bar magnet is bent into semicircular, okay, bent into semicircular bar magnet. Okay, find the ratio of find ratio of original and new magnetic moment. Okay, original and new. That question, most of the time they will just use the word magnetic moment. They will not use the word magnetic dipole moment, because magnetic dipole moment is same as the magnetic moment. Okay, to find the ratio of original magnetic moment is how much, and after bending the new magnet has formed, what is the magnetic moment of that one? Let's find out the ratio of these two. Okay, please tell me how much is that coming. Is the pole strength going to change? No. Unless or until you cut it along the length, the pole strength is never going to change. Okay. So please tell me how much is that coming? How much is coming? Tell me. See, what will be the initially magnetic moment? So initially magnetic moment will be equal to m into L. Now finally what will happen when you bend it? Can I say now the separation between these two south and north pole will become 2r now, because it's a semicircular part, isn't it? So new magnetic moment, if you write it, you will write it pole strength did not change. Now the separation between the pole is 2r now, right or not? Now the problem is one side we have the L and other side we have the R. Unless or until I know the relation between L and R, my ratio won't be solved, isn't it? So can you tell me what is the relation between L and R? Can we say that L is also equal to pi r? Please tell me. Can we write it? L is also equal to pi into r. Why pi into r? Because here in this question we are getting L equal to pi into r, because the same bar magnet is bent into the circular form, na? So that's why L equal to what? Pi into r. Understood? So now if I write m by new magnetic moment, what are we doing? M by m into 2r, m into, can I write it? L is equal to pi r also, divided by m to 2r. M r get cancel out. What I am getting now, the ratio? Pi by 2. Please tell me, understood this question? Please tell me. So this is about the bar magnet and its magnetic dipole moment calculation. Okay. There is one question for all of you. One one thing I wanted to ask. Uh, Tomorrow in the afternoon time, will you be free? Just for tomorrow, I am asking. Actually, next week, Monday onward, Monday to Saturday, okay, na? I will be going outside Tirupati and Madurai. So, for that week, we will not have the class. So, I was thinking if tomorrow you are free in the afternoon, so I will be taking one class, maybe 2 hour class in the afternoon. And Saturday, Sunday, as usual, 1 hour class will be there. So that lot of thing will be covered before we go to the before I go out station. Okay, na? And once we will come back, so for 1 2 week, Sunday class we will extend it to the 2 hour. Okay. So please tell me, are you free in the afternoon time tomorrow? Please tell me, all of you.
Yes, sir.
Afternoon, what time I can plan? Tell me, 2 to 4. Can we plan it?
Okay, sir.
Please tell me, all of you, if you are comfortable, then I will plan. Okay. Otherwise, we will just extend our class on Sunday. So please tell me, 2 to 4, will you be free? So tomorrow, okay, Charan agrees. Lokesh, Minal, you also?
Okay, sir.
Right. Just for tomorrow and Sunday morning class. Okay, na? After that, again, it will be just 1 hour class in the evening. And Sunday, we will try to have it a little bit extra. Okay. And don't worry about your syllabus. Okay. It will be still comfortably done. Okay. So tomorrow we'll meet it afternoon 2 to 4. Okay. Right. Okay. Or let's meet it at 2 p.m. Then we will see if you are tired. Then we will keep it up to 2 to 3 and one evening class. Okay. So evening class will be as it is. Only this is the extra part. Okay. Right, everyone. Let's meet it tomorrow then.